Hey everybody, we are on our 7th day of Unit 0. Today is September 1st, 2020. Then our virtual class norms, I'm not going to read over these because these have been the same every day. Just make sure that we are abiding by all of them. And just a couple reminders, do your exit tickets. These are the biggest part of your grade right now. Do your exit tickets and come to live class if you're watching this video. Then our objectives for today. So today we'll basically be reviewing division. So we have our dividend, our divisor, quotient, and remainder. So remember that our divisor goes here, just like how in the picture shows. Our dividend goes there, remainder. But we're going to learn what to do with remainders, and then our quotient, basically our answer. Alright, so now we're going to go ahead and get started with our first video, divide by taking out factors of 10. And this is almost like multiplying by taking out factors of 10.
What we're going to do in this video is get some practice doing division with numbers that are multiples of 10, 100, 1000, things like that. So let's say we wanted to compute what 2,400 divided by 30 is. Pause this video and see if you can calculate it using whatever strategy makes sense to you. All right, so let's think about this together. And I'm going to show you how my brain likes to handle this. We'll do this out on my little digital blackboard. But eventually, you'll be able to do things like this in your head. So 2,400 or 2,400 divided by 30, that is the same thing as 2,400 over 30. So this is just another way of saying 2,400 divided by 30. Now the reason why I wrote it this way is because you can now write each of these, the numerator and the denominators, as the product of some number and either 10 or 100 or 1,000. So 2,400, that's the same thing as 24 times 100. 24 times 100. And I knew that I was like, okay, I've got these two zeros at the end, so you could view this literally as 24 hundreds. And then 30 you can view as, we got 1 0 here, so it's 3 tens. The 3 is in the tens place. So 3 times 10. Now what's valuable about thinking of it this way is you can separately divide the 24 by the 3 and then the 100 by the 10. So this is the same thing as, let me do this way, as that times that. And so we have 24 divided by 3, 24 divided by 3 times 100, 100 divided by 10. Now 24 divided by 3, you might already know, that is going to be 8. 3 times 8 is 24. So this is going to be, this is going to be equal to 8. And what's 100 divided by 10? Well, 100 divided by 10 is just going to be 10. So our quotient, I guess you could say, is going to be 8 times 10, or it's going to be equal to 80. And we're done. And you might notice something interesting here. So if I take my 24 and divide it by my 3, I'm going to get this 8. And then if I take 2 zeros and if I take away another 0, I'm going to be left with 1 0 right over here. So you get 80. But why did that thing with the zeros work? Because you're really taking 24 hundreds divided by 3 tens. So 100 divided by 10, well, you're going to lose a 0. That's going to be equal to 10, which has only 1.
And then I included a picture just to show a summary of what he did in his work there. Moving on. Now we're going to talk about dividing by 2 digits.
Let's divide 7,182 by 42. And what's different here is we're now dividing by a 2-digit number, not a 1-digit number, but the same idea holds. So we say, hey, how many times does 42 go into 7? Well, it doesn't really go into 7 at all. So let's add one more place value. How many times does 42 go into 71? Well, it goes into 71 one time. And we're really, just a reminder, I'm just doing the process where we say, hey, 42 goes into 71 one time, but we're really saying 42 goes into 7100 100 times, because we're putting this one in the hundreds place. But let's put that on the side for a little bit and focus on the process. So 1 times 42 is 42, and now we subtract. Now, you might be able to do 71 minus 42 in your head, knowing, hey, 72 minus 42 would be 30, so 71 minus 42 would be 29, but we could also do it by regrouping. To regroup, you want to subtract a 2 from a 1. Well, that's not so, you can't really do that in any traditional way. So let's take a 10 from the 70, so that becomes a 60, and give that 10 to the ones place, and then that becomes an 11. And so 11 minus 2 is 9, and 6 minus 4 is 2. So you get 29, and we can bring down the next place value. Bring down an 8. And now this is where the art happens when we're dividing by a multi-digit number right over here. We have to estimate how many times does 42 go into 298. And sometimes it might involve a little bit of trial and error. So you really just kind of have to eyeball it. If you make a mistake, try again. The way you know you make a mistake is if you say it goes into it 9 times and you do 9 times 42 and you get a number larger than 298, then you overestimated. If you say it goes into it 3 times and you do 3 times 42, you get some number here. When you subtract, you get something larger than 42, then you also made a mistake and you have to adjust upwards. But let's see if we can eyeball it. So this is roughly 40. This is roughly 300. 40 goes into 300 the same times as 4 goes into 30, so it's going to be roughly 7. Roughly 7. Let's see if that's right. 7 times 2 is 14. 7 times 1 is 28, plus 1 is 29. So it got pretty close. My remainder here, notice 294 is less than 298, so I'm cool there. And my remainder is less than 42, so I'm cool as well. So now let's add another place value. Let's bring this 2 down. And here we're just asking ourselves, how many times does 42 go into 42? Well, 42 goes into 42 exactly one time. 1 times 42 is 42, and we have no remainder. So this one luckily divided exactly. 42 goes into 7,182 exactly 171 times.
And then I just included this in the presentation just to show you what it would look like, all of his work looked like without it moving. So I'm going to talk through some of the ways that I'll be asking for our answer. So in this example, I divided 90 divided by 12. So as you can see, 12 does not go into 90 perfectly right here. So to interpret an answer as a remainder, you're going to figure out how many times does 12 go into 90, how many times does 12 go into 90, and then figure out how much is left over. So in this problem, 12 goes into 90 7 times, and 12 times 7 is 84, but then we have 6 left over. So your answer is 7 remainder 6. So that is one way you can write your division answers to a problem. Say I ask you to interpret it as a decimal and a fraction. So if we kept going with this division problem, so we stopped here in the other problem when we had a remainder of 6, we're going to bring down a 0, just like how I did here, and then we're going to figure out how many times does 12 go into 60, and then we'll put that up here. And we know that 12 goes into 65 times, and then there would be nothing left. We just have to remember to put that decimal point because we kept adding a 0. So then our decimal answer would be 7.5. In order to make 7.5 into a fraction, we know that the 5 in the decimal point, because it's the first place value to the right of the decimal point, is 5/10. So we can just write 7 and 5/10. Or if we want to simplify it, we can write 7 and 1/2, or 15 over 2. And if you don't understand what this fraction is yet, we will be going over fractions a lot this year. So these are the 3 ways I'm going to ask you for an answer: remainder as amount left over, a decimal, or a fraction. I know that was a lot at once, but you can watch this video again just to see what I was talking about. Once again, I included another example. So in this example, it's 497 divided by 25. I included what our answer would be as a remainder, as amount left over, as a decimal, and a fraction. Here, when I found the decimal, it was 0.88. So to make that a fraction, since we know that 8 is in the hundredths place, we know that we have 88 hundredths. Sorry, that goes far. Hundredths, so that is the same as 88 over 100. And then we just add our whole number next to it. Next up, we have our estimation video.
What we want to do in this video is get some practice estimating multi-digit division problems. So here we're asked to estimate 794 divided by 18. Now, if you wanted to get the exact answer, you'd probably have to do, in fact, you would have to do some long division or maybe use a calculator. But the whole point here is to get some practice estimating. So pause this video and try to see if you can figure this out without even using any pencil or paper. All right, so now let's do this together. So I'll tell you what my brain does. My brain says that, look, 794 is awfully close to 800, and then 18 is close to 20. And so I would say this is going to be roughly the same thing as 800. It's going to be roughly equal to 800 divided by 20. Is it going to be exactly equal? No. But these are the numbers closest to the numbers there that it's easy for me to divide in my head. So for example, I would then say, if I was just doing this purely in my head, I would say, well, 100 divided by 20 is 5. So 800 divided by 20 is equal to 40. Or another way to think about it, 800 over 20, if we divide the numerator and denominator by 10, it's the same thing as 80 over 2, which is equal to 40. So 794 divided by 18 definitely isn't exactly 40, but it's going to be close to 40. And especially of these choices right over here, it's definitely going to be much closer to 40 than 84 or definitely 400. So we're going to go with that.
Alright, so that was the end of our video. Don't forget to finish your independent practice. Do the exit ticket on Edulastic. If you have trouble, please G-chat me. Truman State, your next class is at 10:20, and UCO, your next class is at 12 p.m. Please stay in this Zoom call to work on the independent practice with Mr. Juarez if you need extra help. Remember to finish the independent practice, turn it in, then do the exit ticket on Edulastic. Have a great day, y'all.